So, as Stephen's paper has wonderfully shown us, practical mathematicians long had connections to maritime voyages, but it's in the 18th century, which I'm going to be talking about, that we begin to find more regular state-funded attempts to embed those kind of skills onto certain elite voyages of scientific exploration. So the first image you can see here, slightly small, I'm afraid, but it's a detail from a print of one of those voyages. It's from the third circumnavigation of Captain James Cook, showing the ship's resolution and discovery in the Society Islands in the 1780s. Just about visible, possibly. Go and look at this on the collections online of the National Maritime Museum if you can't see it here. But here, you can just about see what are probably meant to be observing tents peeking out there. So they mark the location of the practical mathematician observers and their precision instrumentation, which is what I'm going to be talking about today. So relatively small number of voyages, but they were, of course, very widely publicised and very influential, paving the way for a more consistent support of survey and mathematical practice in the 19th century by the Royal Navy. So by practical mathematician, I include those applying as well as teaching or writing in support of the application of mathematics to a whole range of activities like navigation, survey, architecture, engineering, ballistics, gauging, instrument making, and so on. And those kinds of skills were, of course, developed within the Navy and the Army. By the 19th century, those were important groups. David Miller has identified as being really fundamental to the sort of disciplinary and institutional development of the physical sciences then. So he talks about practical mathematicians as a group and scientific servicemen as a group, joining with Cambridge mathematicians to form things like the Astronomical Society as a really key development. I'm talking about something a little bit earlier than that. And in the second half of the 18th century, the mathematicians on board the ships that I'm going to be talking about and pioneering what I call precision exploration were supernumeraries. They were civilians. They weren't mariners. They weren't naval officers. They had skills that brought them a range of quite irregular opportunities, that precarious kind of life that Stephen's already mentioned. So in this talk, I'm going to talk a bit about why they become important, how they get these opportunities, a little bit about who they were and what the sort of consequences of this move were. I should note, of course, too, that this was not only a British phenomenon at this period at all. There were also Russian, Spanish, and especially French voyages of scientific exploration and mathematicians on board those too. But the British context is the one that I'm going to focus on today. So as a sort of joining point between some of what Stephen's talked about and what I'm going to be talking about in the sort of second half of the 18th century, I'll just mention Edmond Halley, who was made a captain, quite surprisingly. So he is an individual who kind of combines a role as a natural philosopher, an astronomer and a mathematician, and a role within the Navy itself. He voyaged abroad to make observations of the southern constellations and a transit of Mercury from the island of St. Helena, which is just visible in that painting detail there, in 1677. So that was long before he became Astronomer Royal, which is in 1720. It was in a brief interlude of peace later on, so Britain often at war in the period I'm talking about. So after the end of the 9 Years' War in the 1690s is when he has that very unusual opportunity to become a captain and to take command of a vessel in a naval voyage, and that was to investigate terrestrial magnetism. So that question about variation of the compass and magnetism remained very live and continued to be in the period I'm going to be talking about. So around the period that Halley was travelling to St. Helena, there were several initiatives in order to try and increase the number of skilled individuals within the Navy, not necessarily coming from the Navy itself, but often from elsewhere. So there were attempts in the 1670s to encourage the use of astronomical methods to find longitude at sea, particularly that problem. And those were being encouraged to rely on precision instruments, astronomical tables, and on calculations. And they were supported by the creation of the Royal Observatory at Greenwich, among other things, also the foundation of the Royal Mathematical School at Christ's Hospital, which was intended to teach boys mathematics and theory before then being apprenticed to a sea captain. The first Astronomer Royal, John Flamsteed, who you can just about see his portrait here, was rather dismissive, there's a sort of a pattern here, of the abilities of most seamen. He blamed ignorance and the poverty of the brain proceeding from obstinate laziness for these individuals not taking on board the kind of work he was developing. But he did offer advice on the development of the curriculum for teaching mathematics and navigation to the Royal Mathematical School, and he also privately taught boys and young men who were intended for sea service as well. He suggested, hopefully with the right combination of sober, diligent pupil and skilled master, you would, after that practical apprenticeship at sea as well, be able to produce inventive and diligent navigators. So this portrait here is shown on the ceiling of the painted hall at the Royal Hospital for Seamen at Greenwich. And here he is acting as master of a slightly different sort to his apprentice, Thomas Weston, who himself also became a teacher of mathematics for navigation, setting up Weston's Academy in Greenwich. Another of Flamsteed's former assistants was James Hodgson, who also became his nephew-in-law. And Hodgson had been an assistant at Greenwich before Weston, so from 1695 to 1702. And he became, after that, one of these London mathematicians. He became a teacher and an author. He was also giving natural philosophical lectures in coffee houses and so on, before he got a permanent position, being appointed as mathematical master to the Royal Hospital School, which you can see in this print here. And he started there in 1709. If we believe what he writes in the textbook that he produced for the pupils that he had there and for other members of the public, if they would buy it, in 1723, his system of the mathematics, if that's anything to go by, then his hope was that boys trained in mathematics and the theory of astronomy and navigation, before again undertaking their practical apprenticeship, would have the potential to apply astronomy to navigation and therefore to improve it. They might, he suggested, make the lunar distance method of finding longitude a practical proposal, something that the Observatory at Greenwich had been founded to make possible. And then in the 1720s, he's suggesting practically this might be the case quite soon. And he said, I quote, "I cannot help thinking that if men would set about it in good earnest, they would not fail to meet with success at sea." So practical, diligent people, putting them on board ship will get us there in the end. Some of the pupils of Hodgson and others at the school there in Christ Hospital did go on to become officers or commanders of ships, others not. They weren't always very happy with the success of their programme. Some took on what was a rather more lowly position, which was to be a schoolmaster on board ships, a naval schoolmaster. Since 1702, they have been, in theory, a position placed on board ships to instruct the boys and men there, not only in theory, but the practical parts of navigation and the art of seamanship. Their competence of the prospective schoolmasters, like that of mathematical school pupils as well, was certified by the Maritime Guild, Trinity House, after being grilled by an examiner that they had appointed. That examiner was always a very mathematical one, so it's clear that that was the most important thing for the schoolmasters to have, rather less that kind of practical education, which of course those on board ship would be getting in other ways. And Hodgson suggested that those naval schoolmasters might take on a more important, more augmented role if they were given the means and support to do so. So I quote, he suggested that let every one of His Majesty's ships of war be provided with a good telescope, a small quadrant and a good timekeeper, and let the teacher of mathematics appointed for that ship be obliged in every port he comes into to make all the observations that happen during the time of his stay there, and let him be obliged at his return home to bring them to the Royal Society or to any person or set of men whom the government shall think fit to appoint for this purpose. And they would then gather that information and add to and improve charts and navigation as a result. He suggested that this would be an effective approach. He said there were others who were calling for 2 or 3 ships, he said, to be sent abroad to put various methods for finding longitude into practice. He said that was unnecessary. We have the right skills, we have the right people, let's just push that a bit further. However, the schoolmasters were poorly paid and they were given rather little status on board ships. And we find that Flamsteed, Hodgson and others continued to lament that mathematical skills were not being more appreciated or recognised within the Navy. Those 2 or 3 ships that Hodgson mentioned and rather dismissed, of course, were being set to work in the second half of the 18th century. And they had considerably more than a schoolmaster or these 3 key instruments on board, although those do remain the key instruments that you want to send your mathematician and observer on board ships with. But we'll see it becomes a lot more augmented than that. The 18th century then was to see a succession, I mentioned conflicts, so there were sort of, after this period, a series of naval conflicts that rather sort of get in the way of being more exploratory or trying out these new things. But the voyages of scientific exploration find their moment after the end of the 7 Years' War, which is in 1763. So the first of the Royal Navy's scientific voyages of exploration is usually identified as being that of the Dolphin, which carried out 2 circumnavigations after this period from 1763, after the end of the 7 Years' War. And it certainly, the Dolphin's voyages signal the Admiralty's burgeoning interest in both ambitious, flagship as it were, kind of voyages and the use of skillful navigators and surveyors on board them. On the second of those 2 circumnavigations, which took place in 1766 to 68, there was on board one individual called John Harrison, not the one you might have heard of, the one who is a clockmaker, but a John Harrison who was the ship's purser, who it turned out was capable of making lunar distance observations in order to fix positions. So there is interest. There are members of the crew who are trying out these still quite novel techniques, though this Harrison was not necessarily capable of the full sort of mathematical hard work in order to process the observations to make them fully comparable, but nevertheless he was able to do something in that direction and was feeding information back. And indeed, the locations that the Dolphin went to were important and fed back to the Admiralty in making their decisions about where to send future voyages. However, crucial to the story of expeditionary astronomers and mathematicians that I'm telling here is a voyage that actually precedes this one and did actually take place still while the 7 Years' War was going on. And that one was, in a way, more in the mould of Halley's trip of 1677. It was again to St. Helena, and it again involved a man who would later go on to become Astronomer Royal. And this time, the voyage was to observe the 1761 transit of Venus. I don't really have time to get into why observing the distance and working out the difference between the Earth and the Sun was an important thing to do at this period, beyond the fact that there were 2 transits of Venus in the 18th century. There had been 2 in the 17th. There would be 2 in the 19th. But we can always get into that in questions if people want to. So Neville Maskelyne and this voyage were to be important and, I've argued, rather overlooked contribution to what becomes a tradition. So Maskelyne's role in this voyage and another one as observer and also as organiser undoubtedly helped him to gain the position of Astronomer Royal, but that wasn't a given at the time that he was doing it. He was a Cambridge graduate and a recognised mathematician from that period. He had become a Fellow of the Royal Society. He was also a curate. So he had connections, he had some recognition, he had some income, but he was also at this period essentially a jobbing astronomer and mathematician. So the Royal Society paid him to be an observer for this voyage, and that was done with a grant from George III, who was suitably convinced by the Royal Society that transits of Venus observations would be beneficial to the nation by demonstrating their scientific prowess and also by improving the accuracy of astronomy. And improving astronomy is important because it improves navigation. That connection is always very clearly made. So there is still at the heart of this the promise of trade and plunder underpinning it. This will be good for empire, for trade, for nation. So Maskelyne took on this kind of paid work for the Royal Society, and then 2 years later also for the Board of Longitude, where he acted as both observer and chaplain on a voyage to Barbados, which was sent out by the Board of Longitude in order to trial 3 different potential methods for finding longitude at sea. So they were being compared and tested to see which of those worked. In between those 2 voyages, he published this work in 1763, The British Mariner's Guide, which supported the practical use of the lunar distance method, and which he had found that he could use with quite some success on his voyage to St. Helena. And he was suggesting that this could become a usable, practical thing for people at sea more generally. If the kind of pre-computed tables that he published in this book could be produced regularly, then it would be a goer, he suggested. It wasn't his sort of first idea, these methods. Such tables have been published by the French astronomer Nicolas Louis de Lacaille beforehand, but his view was this sort of setting in motion an idea that you could publish these in advance regularly and produce something that could be taken to sea by mariners and put to use. So this book perhaps could be seen as a sort of prospectus for potential employment by Maskelyne, whether that would be in a role as teacher or as expeditionary astronomer. Again, he's proving his ability to use these techniques and instruments, or as perhaps a paid author of tables like this coming out regularly in the future. He couldn't know in 1763 that the then new Astronomer Royal, Nathaniel Bliss, would die after only 2 years in post, unexpectedly. Maskelyne's assistant on the St. Helena voyage in 1761 was Robert Waddington, whose career has been looked into by Jim Bennett, and he's shown that it's a kind of shadow to that of Maskelyne, an alternative and a more precarious one, lacking perhaps the university education that Maskelyne had, his contacts in London, perhaps also just a question of luck too. So Waddington had likewise, alongside and also separately to Maskelyne, made successful longitude observations by lunar distance, and he had also gone home and, just in advance, published a book. That's his practical method for finding the longitude and latitude of ships at sea. And again, this is demonstrating the potential practicality of the use of the lunar distance method more generally. But his career was to remain what Maskelyne's might have been. He was the mathematical practitioner who was teaching mathematics and navigation, selling and improving instruments, and publishing mathematical and navigational textbooks like this, but other ones after as well. He had hopes that he might receive a reward from the Board of Longitude or some more permanent position or some form of patronage, but those hopes came to nothing. But his rather patchwork and piecemeal career is very much more typical than Maskelyne's turned out to be for the kinds of expeditionary astronomers that I'll be talking about further as the talk goes on. So after he came back from Barbados, Maskelyne found that indeed he was to become Astronomer Royal. He'd put himself in a good position, and Bliss's death meant there was a vacancy. Being Astronomer Royal also meant that either officially ex officio from that post or just by dint of being there, he would become the chief authority on astronomy and navigation as something so very closely connected with that area within the Royal Society. So the Astronomer Royal, unless they fell out with the president of the Royal Society, which did happen on more than one occasion, but generally that was a position that would always be on council at the Royal Society, always there to advise. He was also necessarily a commissioner of longitude as well, so had a connection through that to the Admiralty. So he found himself in a position to exercise patronage in a number of ways on behalf of these practical mathematicians and observers by inserting them onto boards, voyages of exploration, and also suites of scientific instruments and instructions for their regular use, something that Hodgson perhaps imagined but never fulfilled at that period. So in his period as an expeditionary astronomer in the earlier 1760s, Maskelyne had learnt very directly about the practicalities of using instruments while at sea and also in temporarily set up observatories on land. I think also an important lesson that he learnt was how to maximise the opportunities that were offered by travelling with instruments and with skilled individuals. just in case something didn't go right. So it turned out that the transit of Venus that he went all that way to observe in 1761 was not visible on the day. There were clouds. So they had nothing much to report back on that, but he'd made sure it couldn't be a wasted voyage, because there was also a project that he had proposed and was supported by the Society to try and observe and measure stellar parallax, making a sort of whole annual series of observations. He's also spending that time, of course, and necessarily, to determine longitude and latitude from the position that he's observing very, very precisely. So that's not just important for the astronomical observation he hoped to make, but also, of course, an important thing that you can add to charts and to be a fixed point from which accurate surveys can be made. He was also investigating the effects of local gravitation. Still, the question of magnetism was being investigated, and tidal observations he certainly made with his assistant too. He also, of course, had made use of the voyage, both there and back, in order to trial the lunar distance method of finding longitude, and gained experience of that, not just making those observations while on board ship and all its difficulties, but actually also of collaborating with the officers on board ship in order to make the relevant observations, which can't just be made by one individual. You do require people to work with you. And it was a learning process that went both ways. He was trying to teach them about the new techniques and different instruments that they might use, but also they were teaching him about things that would make it easier, or where you can do it practically in the context that they would have been so much more familiar with than he was. So all of these lessons Maskelyne was able to put to use when he becomes the organiser much more than the participant in expeditionary astronomy. So the hugely important next opportunity for him was the 1769 transit of Venus. And here Maskelyne is working between the Royal Society and the Board of Longitude, and with very significant funding, this time even more so from George III and from the Admiralty. Maskelyne was asked to appoint the observers, to direct the purchase of instruments, and to write instructions for 5 expeditions, some Royal Society sponsored, some Board of Longitude sponsored. The most famous of these is the one that went on board the Endeavour with Lieutenant James Cook in command, and made the observations from Tahiti. And you can see in the print here the location from which they observed in Tahiti, known as Fort Venus. They also went much further than that, of course, and again, it's famous as a circumnavigation. They were intending and went on to explore extensively the South Seas, reaching New Zealand, you may have seen from the newspapers, 250 years ago last week. So the appointed observer for this expedition on board that one ship was former Royal Observatory assistant Charles Green. These observations here, these are ones made by Green, just showing Venus passing into the disk of the sun. That's what they were observing, this black dot crossing a bright solar disk. And the ones above are those made by Cook, who was he was the assistant astronomer, as well as being in command of the expedition. He had proved his abilities elsewhere as an observer in order to do this. But Green, subsequently to this, was also being asked to put a whole suite of instruments, of precision instruments, to use in support of a whole range of observations of astronomy, navigation, geodesy, survey, hydrography, geomagnetism, and more. So it's a physical sciences complement of collection of data to the gathering of botanical, zoological, and ethnographic information that the voyage also supported, famously with Joseph Banks being on board. So this was a successful and important voyage. There was a clear astronomical objective with the transit of Venus in this one that wasn't necessarily there in the subsequent voyages. And Maskelyne made quite a crucial step in order to try and continue what had been started here. That is this placement of Board of Longitude appointed mathematical observers and the instruments on board ships. It could have been perhaps a relative one-off for 1769. This was the last transit of Venus that was going to happen before 1874. We know that within months of his return on the Endeavour, Cook was being asked to go out as command again of another voyage of scientific exploration. The first had been very successful. That was to go out with 2 ships. And again, it was to include naturalists and artists, but it didn't initially have greater mathematical or observational expertise than that which Cook himself and his officers had. But Maskelyne notes the opportunity, and he wrote to Lord Sandwich, who was then First Lord of the Admiralty and a Commissioner of Longitude, suggesting that the planned voyage, sorry for the long quote again, but his suggestion was that it could be rendered more serviceable to the improvement of geography and navigation than it can otherwise be if the ship is furnished with astronomical instruments such as this board, that is the Board of Longitude, hath the disposal of, or can obtain the use of from the Royal Society, and also some of the longitude watches. And above all, if a proper person could be sent out to make use of those instruments and teach the officers on board the ship the method of finding the longitude, and that method being both by lunar distance, by astronomy, and also by timekeepers, the longitude watches that he mentions there. So very much supporting both of those complementary methods of improving both navigation and also surveying. The Board of Longitude supported this proposal. Sandwich supported it, the board supported it, and Maskelyne was then asked to go and appoint 2 suitable observers, 1 for each of the ships, and to, I quote, prepare a draft of instructions proper for the said persons, and also a list of the necessary instruments. And this is the list that he comes up with for Cook's second voyage. That's quite a lot more than those 3, the sort of the telescope, the quadrant, and the timekeeper. And you can see the longitude watches that he's mentioned, that's Larkham Kendall's copy of Harrison's Sea Watch, known as H4, and also John Arnold's timekeepers, and an awful lot else. And you'll see magnetism is still something that they're interested in, variation compasses, and a whole lot of instruments that you can only really use by setting up on land. You can't use astronomical regulators on board a ship because they're pendulum clocks. They have to be set up on land, so the hope is whenever the ship stops long enough somewhere, you can set up under your portable observatory, make the observations to establish local time, latitude and longitude very precisely as a fixed point, which is always going to then improve further charting and future navigation. This now, because of Maskelyne's insertion to the discussion at that point, does become the pattern. And the subsequent voyages of exploration in the 18th century went on to carry observers and a number of these instruments. It becomes an increasingly standardized kind of list. You won't be able to read these, but these are other examples of lists that Maskelyne draws up. This is handwriting that were delivered. This is for Cook's third voyage. This is the voyage of George Vancouver to the Northwest Pacific, and there are others too. So there is this now standard. He can sort of set off, he knows exactly what the first few instruments, there might be some more experimental ones to throw in a bit later on, new things that have come up, see how they work. And also at the bottom, there's always a list of texts as well. So instruments are one thing, but you also need your nautical almanac. So these are the predictive tables for finding longitude at sea that he talked about in the British Mariner's Guide. As Astronomer Royal, he makes sure they are published in advance for several years, so you can take with you several years' worth, hopefully that will take you all the way through the voyage. There are also the requisite tables that support the use of the almanac. There are charts, there are prior sort of observation accounts of voyages that will be taken on board as well. So there's a whole series of kind of paper instruments, as it were, as well as physical object instruments and his instructions that they should keep, close records, logs, and so on, and pass them back to the Astronomer Royal when they return home. Given Maskelyne's role in appointing these mathematical practitioners as observers, it's not surprising that he knew them personally in many cases, or obviously got to know all of them personally. And he knew many of them through those other routes to patronage that he could also exercise, which was principally through being able to appoint individuals as assistant at the Royal Observatory. There was only ever one assistant at a time to Maskelyne, but he had quite a number of them, because he clearly saw it as something of a training ground. You could get a very practical training on top of mathematical knowledge and experience, and that would set you up for other kinds of work in the future. There was also a requirement for mathematically literate computers in order to compute the nautical almanac, so for those volumes to appear in advance, and other kinds of ad hoc computation that the Board of Longitude and sometimes the Royal Society required. And Maskelyne tended to be the one who was organising this and could ask people. So the ones in red here are individuals who he knew through these other channels and will have worked for him at the observatory or on the Nautical Almanac before they're being chosen to be an expeditionary observer for one of these voyages. So expeditionary astronomer was, for these individuals, one of a possible series of such kinds of work. Maskelyne hired, as you can see, some of these people repeatedly, both because they proved their skill and he could trust them, but also because he felt an obligation often to them of support and patronage. So there are examples where a former assistant or computer found that they were in financial difficulty, and then Maskelyne is able to sort of step in with a piece of work to help them. So these kinds of regular opportunities and support, and then also, of course, the sort of degree of fame that could be earned by connection to what were becoming increasingly sort of well-known and respected voyages, led some of these people to what were the very few secure roles for mathematicians at this period. And that was particularly the case for the two observers earmarked by Maskelyne for Cook's second voyage, which were William Wales and William Bailey. And just briefly, as I say a few words about them. It's not really known how William Wales, who came from Yorkshire from relatively humble origins, as far as we know, and we don't really know where he gained his mathematical expertise, but he was able to demonstrate it through the pages of what was the chief periodical of the period for supporting mathematics for leisure, which was the Lady's Diary. So he appears there. And then later he is introduced to Maskelyne after he moves down to London, and he is married then to the sister of Charles Green, who'd been an assistant at the Royal Observatory. So that is something that tells us about the perhaps social connections that existed amongst mathematicians in London. So he marries in 1765, and within months after that, Maskelyne has got to know him and has appointed him to be one of the first computers of the Nautical Almanac. Then, in 1769, he's appointed to be a transit of Venus observer going to Hudson's Bay, now in Canada, and then, of course, in 1772 as an observer for Cook's second voyage. In between, he undertook computational work for the Nautical Almanac and for the Board of Longitude, including of his own observations that he'd made on the voyages with Cook. And ultimately, he was able to secure the position that Hodgson had once had of Master of the Royal Mathematical School. In his final years, he became secretary to the Board of Longitude as well. When he was out in the South Pacific, he had the opportunity to name some islands, and he named them after Maskelyne. And in his account, he says that he named them, quote, by the name of a person to whom I owe very much indeed, one who took me by the hand when I was friendless and never forsook me when I had occasion for help. William Bailey was the son of a farmer in Wiltshire, but took the opportunity to learn mathematics from an exciseman, so that's another area in which practical mathematics was important, who was living nearby. And he obviously had aptitude for it. He went on to teach at schools in the West Country. And in 1766, Maskelyne had probably heard about him because he had family connections in Wiltshire, and he appointed him to be his assistant at Greenwich. There he received the practical training as a complement to the mathematical education that he already had, and that allows him then to be appointed as an observer for the transit of Venus, which he observed in Norway with Jeremiah Dixon, he was the son of a coal miner, veteran of the 1761 transit of Venus expeditions, and also of surveying the Mason-Dixon line between Pennsylvania and Maryland, which Maskelyne had also helped to organise and equip. Bailey returned to his position at Greenwich, but was then appointed both to Cook's second and third voyages. This image is from the third voyage, and you probably won't, but right here you might just be able to see an observer bending over a barrel looking at an astronomical quadrant, and that could well be William Bailey. When he returns home, he is paid again by the Board of Longitude to compute and publish the observations that he'd made, which is the publication you see here. And then in 1785, he's appointed headmaster at the Royal Naval Academy in Portsmouth. He remained there until he was pensioned off in 1807, when the institution was transformed into the Royal Naval College. William Gooch is an example of someone who wasn't known to Maskelyne through these routes as Greenwich assistant or nautical almanac observer, but he was a keen young mathematician who sadly died on the voyage that he was on when he was killed in Hawaii. But he'd been suggested to Maskelyne by a friend and a fellow commissioner of Longitude, who was Samuel Vince. Again, Gooch had the sort of mathematical training, but he didn't necessarily have the practical one, so he was required, despite Vince vouching for him and his practical expertise, Maskelyne brought him to Greenwich in order to observe how he observed for a period. And Gooch writes all of this to his parents. You can follow this as these papers are all online at Cambridge Digital Library if you want to read them. And he was a very good correspondent to his parents, which helps us enormously. So he talks about how the Astronomer Royal attended very closely to what he was doing for practice, observing his accuracy, seeing how he set up and how he could observe the going of the observatory's clock, something that he would have to do, of course, with a portable clock set up under a portable observatory when he would be overseas. This letter to his mother, written when he was at Greenwich, records that Maskelyne raised a toast to him after dinner saying, "Success to your expedition, Mr. G." Sadly, it wasn't. But the majority of observers that Maskelyne appointed could be classed as mathematical practitioners of the sort who perhaps moved from the provinces to London and took up the opportunities that their skills could offer them in a capital city and a port city. A few, like Cook himself, were naval officers, and they gained their mathematical and observing skills there, but usually by dint of their own efforts, beginning to see that this could be a way of finding advancement in the Navy, but without it necessarily yet being something that was supported in any kind of official way. So James King too, who was second lieutenant on the Resolution, third voyage, but he'd been granted leave to study, and this is where he had developed his knowledge of various scientific studies in the 1770s, which allowed him to be recommended not just as an officer, but also as an observer for that voyage. All, of course, of the Board of Longitude observers, as I've mentioned, were charged with teaching while on board the voyages they went on, as well as carrying out their observations. And this was really important for Maskelyne to try and push the use of both the lunar distance method and the use of timekeepers at sea. And we can trace the influence of that, I think. You get people like Vancouver and William Bligh, who are very important, renowned naval navigators. They benefit from being on voyages with Cook, but also from having been on board ships with Wales and Bailey. By the end of the 18th century, we find that the Navy itself is beginning to be able to supply much of what only Maskelyne and the Board of Longitude and the Royal Society could then supply in the mid-century. So while you have these sort of markers of precision exploration, the Tent Observatory, something that was designed by William Bailey on the second voyage, Cook, the precision instruments by renowned, known London makers, these start to be things that the Navy Board can supply, and they can circumvent. They don't now need to go to the experts that Maskelyne leads. And by the 19th century, these sketches, just to finish, produced in the 1830s and 40s by the naval officer Owen Stanley, show that what had been the provenance of these civilian supernumerary mathematical practitioners and observers has become something that's really the business of naval officers themselves. So Stanley had been educated at the Royal Naval College in the 1820s. At that time, his education, mathematical education, was supported by James Edmond as Professor of Mathematics, and he had once been a Board of Longitude appointed observer, had gone on Matthew Flinders' Australian circumnavigation in the very early part of the 19th century. Owen, through this education, is able to join a survey voyage to South America in 1830, becomes a scientific officer in 1836 on a voyage to the Arctic, and in 1846 becomes commander of HMS Rattlesnake, which was the survey voyage to Australia, also perhaps best known for the one in which Thomas Henry Huxley was naturalist and assistant surgeon. So these sketches show those markers of precision instrumentation, the observing tents, the instruments and the knowledge that they're required, so the concomitant use of the mathematical and astronomical tables, much pen and paper calculation and notation. So it's the business here of naval officers, but as we'll hear in the final lecture today, of course, there were still often good reasons going forward for mathematical and astronomical experts to also still be mobile. Thank you.
Thank you very much. 2 questions on the Royal Mathematical School. Is it correct to associate its founding with Pepys? And how did it link with the Admiralty decline? Is this in the 20th century between the wars, or?
The founder of the mathematical school was Jonas Moore, who was in the Board of Ordnance, and he was also the founder, the real key mover in the founder of the Royal Observatory as well. So he is someone who's a practical mathematician, but gets quite a high role. He starts off surveying. He surveys the fens and things like that, but gains a position of patronage, and he is patron to Flamsteed and others. So it's through him. Pepys, because of his role as Secretary to the Navy, does become involved as well. And Rob Iliff has written about the discussions that Newton, Flamsteed and Pepys are having about what sort of curriculum it should be, how theoretical, how practical, and so on. I probably defer the question about the decline of the Navy to others. I think declines are always relative.
Did much happen amalgamating the data that was collected afterwards? Or did people just have to buy somebody's publication and work with it and make their own deductions from it?
No, these are being... I don't think I can go backwards. They're being, as I was saying, the observations that Bailey and Wales made, for example, were being published officially by the Admiralty. So the Board of Longitude continues to pay them to do the calculations, to assemble the observations and put them out there. So, yeah, there's very much an attempt to make this data available, to make it useful. By the end of the century, you've got a hydrographic office for the Navy, and they are very much trying to make this available. You get the charts being published. The start of the survey voyages, of course, lead to the Admiralty charts and attempt to really cover as much as possible. So, yeah, make it very much available. Just there's one. I think that was the first. Oh, sorry.
I want to ask, where were this maths? Was it secret? Was it an official secret?
No, it wasn't. And none of the, for example, Longitude stuff was. So, the production of watches or the methods to find longitude by astronomy were published. And the view very much from those who aren't trying to make money from it, so someone like John Harrison, the clockmaker, is quite keen on keeping his things secret because he wants to be able to sell watches. So, it's a trade protected craft secret. For the men of science, the mathematicians, the natural philosophers involved, the view is very much make this available and that will just improve our methods. And I think it's a very sort of free trade view in a sense. Britain is already at an advantage perhaps through its connections, through its navy. So their assumption is that anything that gets better is really going to benefit us first, more than anyone else, I think. Yes. Oh.
You mentioned that mathematicians were on ships of war. So Nelson, for instance, in Trafalgar, he had mathematicians on a ship, did he?
No, I mean, these are voyages of exploration, so they are His Majesty's ships, and they are doing very particular things with instruments that other ships wouldn't have had. You do get a mathematician. So the schoolmasters, in theory, were going on ships of war throughout the 18th century, and there were, as far as we can track, really quite a number of them. They weren't necessarily on every ship, but they were very much around. And so, midshipmen, for example, were very regularly getting a mathematical training right through the 18th century and into the 19th. Keeps them occupied occasionally. War can be very boring. So that may be one way to keep the youngsters out of trouble.
Can you say something about the history of what you call the method of longitude for, I can't remember words. The distance of the moon.
The lunar distance.
The lunar distance for navigation and how it works.
Yeah, well, very briefly. I mean, technically it's quite complicated, and I'd recommend you read Derek Houser's Greenwich Time and Longitude, which has got some great appendices really on how these things work. Or indeed, Wikipedia is quite good on some of these technical articles. But essentially you're looking, once they could, more or less, practically speaking, map the motions of the moon. And the theory of the moon is something for longitude that Flamsteed, that Newton struggled with in the 18th century, and this is the key moment the Board of Longitude is involved with. Tobias Mayer, borrowing mathematics from the continent, using Newton's theory, using observations, produces a practical enough theory that can predict the motion of the moon well enough that you can then predict where it will be vis-a-vis the background of the stars, the fixed stars, as it were. So what the Nautical Almanac shows is where the position of the moon is, or other features in the sky, are relative to particular stars. So what's known as the clock stars are mapped very carefully at Greenwich and are then used as fixed points against which you can predict where the moon should be at Greenwich time, wherever you are around the world. So what you're using, you're making a fix of local time while you're on board ship or on land overseas, and then you're using the lunar distance method to give you Greenwich time. And then you can extrapolate longitude from that.